Okay, our problem is 332. Determine the unstretched length of spring AC if a force P is equal to 80 newtons, causes the angle theta, which is equal to 60 degrees for equilibrium. Chord AB is 0.2 meters long. Take the stiffness of the spring K as 500 newtons per meter. Now we pull a cord and the spring from point A. Therefore, it becomes in equilibrium at a certain position. The cord and the spring is hinged at points B and C respectively, and I pull the system from point A. As a result, this spring elongates. Well, the distance between point B and C is given to us. It is 0.4 meters. And the length of AB is also given, as it is seen. It is 0.2 meters. Therefore, first thing that I have to do is to calculate the AC, because I have to calculate the elongated length of AC. So after the length AC, after I apply the force, then I have to calculate the elongation in the spring. In order to do that, I have to determine the force coming to the spring. And at the end, after calculating the elongation, I will subtract it from the length AC, and I will find the original length of the spring AC. Okay, this is what I'm going to do. Of course, first thing that I have to do is to find the AC. I can easily do it because I know the length AB and BC, and I know angle theta. Therefore, I can use cosine theorem to calculate the length AC. This is what I am going to do. So AC is equal to square root of AB square plus BC square. So this is the length from A to B, and this is the length from B to C, minus 2 AB BC multiplied by cosine theta. I know all the values. AB is equal to 0.2, BC is equal to 0.4, and therefore I can easily find the value, the length of AC. It is 0.346 meters. Okay, next thing is to find the force that acts on the spring in equilibrium. But the point is, I don't know the force that acts on the cord as well. So this is FAB is the force acts on the cord, and Fy is the force which acts on the spring. I just choose it towards the spring. I write the equilibrium at point A, and I assume that X is the horizontal axis and Y is the vertical axis. I have the pulling force P. I know that spring is, so basically spring is try to pull it towards point C. So this is why I choose this direction, but doesn't matter. And it is the same for the FAB. Certainly the spring Y makes an angle of gamma. I call this angle as gamma. Now let's find first the angle gamma. I can easily do that because there exists a similarity between my triangles, I know that again I will use the cosine theorem. So the gamma is facing the edge AB, right? And so let's see it here. So this is gamma. This angle is gamma and it is facing the AB. Okay. So from here I can calculate the cosine gamma. Cosine gamma, or in other words, let's write the cosine theorem. AB square is equal to AC square plus BC square minus 2AC multiplied by BC multiplied by cosine gamma. From here I can calculate the cosine gamma by rearranging this expression. It is AB square minus AC square minus BC square. I just take these terms to the other side of the equation and divide the whole system with the coefficient of cosine gamma. It is minus 2 AC multiplied by BC. Now this gives me a value of 0.866, and from here I can say that gamma is equal to 30 degrees. Now I know the angle. I can write all the forces in Cartesian form. Since I know the angles, I can easily calculate the unit vectors also. So remember that x is the horizontal and y is the vertical axis. As a result, P is equal to minus 80 j vector. FAB, the force acting on the chord, is, let's say that the magnitude is Fi, okay? So as a result, it is minus Fi cosine theta plus Fi sine theta j vector. As you see, the FAB has positive y and negative x component, but doesn't matter, you can take it arbitrarily as soon as you know the unit vector. You will, if you choose the direction in wrong, certainly you will find the magnitude of Fi negative. Okay, now the force that's coming from the spring is, we say that it is Fi, the magnitude is Fi, and it is equal to Fi multiplied by cosine gamma I plus Fi multiplied by, sorry, please correct it, this has to be sine, by the way. So it has to be sine gamma. Again, it is the same here. It has to be sine gamma. So sum of the forces in x and in y direction has to be equal to 0. Therefore, from the x direction, I have Fy cosine gamma minus Fi cosine theta. I don't have any x component coming from the pulling force. So this has to be equal to 0. Again, I don't know the Fy and I don't know the Fi. From the y component in y direction, or sum of the forces in y direction has to be equal to 0. And as a result, it is Fi sine theta plus Fi sine gamma minus 80. So this comes from the pulling force, has to be equal to 0. Now I have two equations, and in fact I have two unknowns. I can solve this set of equations. You can use different techniques. In fact, you can use back substitution, or you can solve the problems simultaneously. So if we look at the second equation, you can take the value of Fi from the second and put it into the first one, or you can do the vice versa. So what we did here is we basically we want to eliminate the Fi, right? So the force in the second equation, we take the Fi from second equation and then put it into the first equation. Okay, so from here or you can take the Fi from the first and put it into the second equation. It seems to be rather easy. If you take the Fi from here, it is Fi cosine gamma divided by cosine theta, and if you substitute it, you will find Fi tangent theta cosine gamma plus Fi sine gamma minus 80 is equal to 0. Now in this equation the only unknown is Fi, and from here you can easily calculate the Fi. Fi is equal to pulling force 80 divided by tangent theta multiplied by cosine gamma plus sine gamma. If I put the angles, so remember that theta is equal to 60 degrees, gamma is equal to 30 degrees, what you are going to get is 46.19 newtons. So this is the force coming from the spring. Now I have to find the elongation of the spring. I call this elongation S. So the force coming from the spring is equal to stiffness of the spring multiplied by its elongation. I know the stiffness of the spring, so K is known, right? It was 500 newtons per meter. Again, I'm using a SI system, so I'm using meters. From here, I can calculate the elongation of the spring S. It is Fi divided by K. So Fi has the value of 46.19 and K has the value of 500. From here I can find the elongation in the spring 0.092. Now next thing is to find the original length. If you subtract the current length of AC, okay, so this length 0.346, if you subtract 0.346, if you subtract the value of 0.092 from 0.346, what you are going to get is the initial length of the spring as 0.253 meters.